So now, how the rearrangement occur according to the step number 3. So previous mechanism, no step number 3, which is no arrangement, because if rearrange occur, it just produce a remain secondary carbocation. So this is why the function of the step 3, which is rearrangement, to identify the most stable carbocation by rearrange first 1 to hydride shift, means we move hydrogen with electron negative charge, and for second either 1 to methyl shift, means we shift CH3 with electron together. So what happened to here, which one must be shift first? So if we have a probability, we have the hydrogen to move, so we just move hydrogen because this is a smallest molecular weight. But if no hydrogen, next step we need to move CH3 group. Okay, how about the example 2, page 93? The statement given also states, write the mechanism. So remember, if the term of the mechanism, it must be related to the type of reaction. So according to the equation given, we have the side product form, means the type of reaction in the reaction is elimination reaction. So prove how elimination of the water occur by using the process of what? This dehydration of alcohol. By using alcohol group, we try to eliminate water to produce carbon-carbon double bond, but the first structure we can classify as a major product according to the Cezanne rule, and the second structure is minor product. So similar for the first question, show how the major product form based on to the step of mechanism. So step number 1, it must be protonation of alcohol. So from the alcohol as your reactant, it must be reacted with our reagent sulfuric acid. So we write down the arrangement of atom in sulfuric acid is like this. We are focused only the hydrogen atom in sulfuric acid because it can supply the proton. So the cleavage occur must be between carbon and oxygen. So this is a stable. What happened? The step 1, we need the proton first, protonated first. So from where? From a lone pair from the alcohol will form a covalently bond with the hydrogen atom, and at the same time the covalently bond between H and O is break, so the 2 electron is directly given toward to the oxygen. So this reaction occurs simultaneously and the product can be formed Okay, at this area we can have O, the first lone pair, remaining bonding pair with hydrogen, and we can trace a new covalently bond from the hydrogen and we take out from the sulfuric acid, and our sulfuric acid can be formed OSO3H. So the ion form oxygen, the 3 lone pair of the electron, and we calculate here valence electron oxygen is 6 minus 7 electron itself, so oxygen become negative charge, so overall charge ion here is negative. And we need to trace here, after proton is added, this oxygen will become less of electron, and we calculate the formal charge here 6 minus 5, so it will become charge positive. So when the proton is added towards the oxygen, the reaction here is a fast reaction. after the protonation occur at the area hydroxyl group, so our target is the covalent bond between carbon and oxygen must be break. So if we refer to the oxygen, it require electron. So where is electron come from? So the covalent bond carbon and oxygen break. So electron will give directly toward to the oxygen. So our product form. So the arrangement of atom, the first here are same. So the differences occur at this area. So bonding carbon and oxygen are break. So the product side is HO. H means the water is formed, means the elimination of water occur. But at the same time, this carbon is less of electron, so it will become charged positive. And we can trace this is a carbocation, but you must be identify this carbocation classification. So C plus attach 1, 2 group of alkyne, so means this is secondary carbocation. So now we need to trace is that the rearrangement occur. So can we form the secondary carbocation is that can be rearranged to form tertiary carbocation, because tertiary carbocation is a more stable. So we try to trace here. So from the secondary carbocation, if rearrangement occur, so neighboring carbon number 1 consists hydrogen. So if I shift this hydride ion, okay, hydride to here, means the product form is a primary carbocation, less stable. So what happened? We check to the carbon number 3. Carbon number 3 consists hydrogen atom and methyl group. So we know that hydrogen atom is the less molecular weight compared to the methyl group. So what happened? We need to shift the hydrogen, include the bonding pair toward to the C plus, and it can become the new carbocation, can be classified as a tertiary. So now we need to shift this group. So we show the arrow should be from bonding pair toward to the C plus ion. So we can label the product form arrow direct, because this is a rearrangement. So we shift hydrogen including 2 electron together, neighboring together, and we just label 1, 2 dash hydride shift above arrow, and the new product can be formed. So after hydride is shifted toward to the secondary carbon, so the product can be formed the new location of the hydrogen. So hydrogen attached carbon here, but the location of carbocation change at this place, and we can trace here this C plus attach 1, 2, 3 carbon, mean 3 alkyl group, and it be classified as a tertiary carbocation. So means tertiary carbocation we can label is a more stable carbocation compared to the first year. This is secondary carbocation. So this is why the uses of rearrangement to identify more stable species form before proceed to eliminate for the hydrogen atom. Okay, next steps. The final step is the formation of alkene by eliminate hydrogen atom. So the criteria of hydrogen atom must be eliminate carbon, neighboring carbon carbocation, either carbon here ataupun this carbon. So the target equation is major. So if the major, this hydrogen atom must be eliminated. So how the process involved? From the tertiary carbocation, it must be reacted again to the OSO3 minus reagent. So what happened? The lone pair at the oxygen atom will attack the proton from the carbon, attack the hydrogen from the carbon neighboring carbocation, and at the same time the two electrons sharing together will stabilize each carbon atom, and neighboring carbon is the carbon carbocation to form the final product, which is a carbon-carbon double bond. So the product can be formed after hydrogen is attacked from the O from SO3H minus. So we can write the final answer. The new of the functional group form, which is carbon-carbon double bond, plus H bonding to the O, SO3H again, mean sulfuric acid remain again formed because sulfuric acid is catalyst, and we trace again either our product as a major or not. Your carbon-carbon double bond attach 1, 2, 3 alkyl group, and this you can classify as a major product.